Yeah, so I'm not like, this is going to be a very short presentation. So I'm not presenting like a technology, but more it's kind of a topic for discussion. And what I'm interested in is more like what's the future of data stores, kind of. Where are we going to? And uh, should they become smarter, and should they also start including some idea of computation within the storage? And that's where I'm trying to get it. I'm not sure if I'm okay, so the idea would be to generate discussion and feedback from you guys and see what you think about it. So the motivation is, well, everyone knows the data is huge, and the data store is collecting all the data. And the data is collected for mainly processing, so at some point you need to compute on the data. So a typical scenario for processing of data, after you collect it, you cleanse it, and then you apply your workflows or functions on the data, which generates other intermediate data, and all this data will go back to your data stores, and then you start over again, cleansing and trying to compute on the data. So my idea is that would it be possible to streamline this process by consolidating data storage with compute backends? So you can think of the compute backends as a Hadoop backend, or a Spark backend, or some custom processing backend. So if we think of combining data, then how can we do that? I have some ideas, but they're out there, so none of them are kind of implemented yet. But the idea is that if you're presenting a data store that has also compute nodes, then what's the idea, for example, of a file? Will it still be a file, or will we need another concept for the data store to store? And one of my ideas is that instead of having files as objects in the data store, you'd have resources, and a resource is a meta entity that can point to either a file or a description language how to generate the file. And the description language could then fire up the computation at the backend that can generate the file on the fly. And you might think, well, why would you want to do this? And the first obvious one is to reduce, for example, data footprint. So you have multiple files that are taking out of space on your data store, but you know how to generate most of these files from just one file. For example, transcoding images or transcoding a huge movie. Instead of storing all the formats of the same movie or images, you could store one parent raw format, and the other formats of the files are just metadata and how to generate these files on the fly. That would be one idea. But this can also go into more complex computation, like scientific computations, and how to generate intermediate data from workflows. So the idea we had is that coming from computing background is that storage and compute nodes. So if you think of compute nodes either being the storage nodes or the compute nodes, we can in a way consolidate them by having them on an overlay network where not just by communicating the actual data, they're communicating what computation can be done on the data. So if you think of transformations on the data, for example, transcoding could be one of the transformation. A data store can ask the nodes in the network, okay, who of these compute nodes in the network can do this computation for me on the fly? Because some user is asking for such an image in some format, but I don't have it readily available. And yeah, that's one way of that being done on an overlay network. So the idea is that this network is doing all these data transformations, and a description language could, in a way, then describe exactly how the data can be generated. So the basics are which functions should be called, maybe where the nodes that functions exist are, and an underlying system of discovering the services and discovering the functions so that the data store can generate files on the fly. If we start looking at every node as more on an overlay network as a more autonomous node on the network without master and controller, the nodes themselves could, in a way, be processors or data stores, but also the data routers. So they're receiving data that they can process, but they're receiving data in kind of packets with a lot of description of the data. So how can it be transformed? Is it part of a workflow? Who's the next function that should be called in this workflow? And this could be all stored in a description language, in a packet, alongside code, alongside the data, and alongside kind of the state of the data. And then you can imagine that the overlay network and the nodes are computing, storing, and moving data around all at the same time. So just from simple then transcoding of images, we could then go a bit further and talk about workflows, like in scientific workflows, where you don't just have a one-step transformation on the data, but you have a sequence of steps that form a workflow. And this can all be represented from a data storage point of view still as a metadata resource file that a user can click and download. And this could be the results file that still need to be generated on the fly. And the data store being connected directly to the compute nodes could invoke the workflow and start the processing to get the results on the fly. So yeah, this short topic, mostly for discussing how data stores or the future of data stores can we see data is becoming also part of compute nodes or consolidation, the mix and match of both of them. How can this happen, or is it viable to happen? And that's what I wanted to present here. For example, some other small examples of some data files that can be represented are kind of real-time data, where you don't have the data at hand, but the user can click on a data file, example, weather data. And the data store is smart enough that okay, this kind of data I don't have, I will generate it now on the fly, and I know how, and the user will just see files coming and going nonetheless. So I hope this can lead to some discussions afterwards, and yeah, thank you for.
Well, it's certainly not intellectually a short talk. I mean, yes. So sorry, I shouldn't start with the questioning. It's is there anybody else who wants to sort of bite off the pointy end? Anybody still feeling clever and hydrated enough? Not the sort of next form of hydration, where I guess that might be so the reception is straight after this, which of course
that would be a good idea.
This may well be the sort of tonic levels that we need to be at. Yes, here's one. Excellent.
Yeah, so all these are issues that have have to be considered, like latency on getting the file. So it's not that's not the idea of making this idea totally transparent to the user that, okay, I have to wait a couple of days to download the file. So in this case, it would be more asynchronous approach. So you get a handle for downloading the file later if it's taking a long time. But that could be an idea, so it's not.
It's fair to say that when you shift paradigm this much from regular files to almost storing workflows and storing pipelines, then I guess the user tooling is going to change a bit too, right? You can't expect to use this with the regular. You're not going to mount this as Samba.
No.
Ooh, wow. I wouldn't. Anybody else?
Well, supporting his observation, most of the data we have or we create, we pay thousands and thousands of euros to buy processors. So we spend so much time producing the data or analyzing the data. And it's very, very simplistic according to me, saying, okay, I produced my data on the fly. You can do it for very, very, very few cases in a scientific environment. But I think most of the time it's just wishful thinking.
No, I mean.
Even a weather prediction, you have your weather data at time X. You want to have it ready after 6 hours, and you usually take 5 hours and 59 minutes to have it. So thinking of everything just producing the weather prediction just on the fly, it's really wishful thinking. This is my idea. Of course, many things you can do very quickly, and the latency becomes negligible. But when we were talking about scientific data, think of LHC data or any other physical experiment or weather or any, maybe biological data. All the reasons why we are here is because we need time to produce this data and to store this data that took so much time to be produced.
Yeah, I mean.
As a chair, I might point out that that's not a question, of course.
The statement.
It's a statement.
Oh,
If you want to take the statement.
Yeah, I agree with you. I mean, when the idea of the concept of it on the fly doesn't mean it has to be instant. It's more the concept of changing the interface of data store is more how you can reproduce, I guess, the data in itself. So if you already did the work in writing your workflow and writing your computation, and your workflow, is generating a bunch of intermediate data that's taking too long, and you know that some of the intermediate data you don't need to store all the time. You can, in a way, make data store smarter, that some of the data you don't need can be generated on the fly, but then that's all up to how the user will.
So this is a goal we should tend to without being so drastic as you say. So maybe when we design our workflows, we should take into account also the aspect you are mentioning. So we should be able to decide or have something decide for us what data must be stored and what data can be created on the fly.
Yeah, so that's where I'm trying to go at some point. That's why I say making data stores smarter. So.
Is that a combined question, or are you just? Who wants to go first?
So maybe not generating data on the fly, but maybe processing data on the fly makes more sense. You have in a client like, I don't know, laptop, mobile phone, or whatever, then you say, okay, give me the out of this data set only this tree which has a Higgs, and give me, by the way, only the energy. I don't need anything else.
Mm-hmm.
So this might be pushing some processing to the storage system, but I think generating raw data, of course, is not possible. Otherwise, you can do only non-graph on it. You don't need accelerators.
Yeah, I agree. It's you can offload some of the data to data store, but the data store then can offload some of its processing to it's compute backends. The idea is,
But you're not saying it's an either or, right? You might retain traditional file capabilities, but in cases where it makes sense, this new semantic could be something that you offer
yeah,
as a potential for those types of data sets that can be more gainfully generated on the fly. That's what you're saying. You're not
yeah.
saying move all computation to this particular file
exactly.
semantic, but if it makes sense, it's just,
it's
for me,
given-
it's conceptually hard to figure out where it might make sense. I'm dumb in that way. You know, what sort of, surely you guys, having looked at this space, have identified particular cases where you've gone, yeah, if we could just replicate that, it's computationally light, but the amount of data is immense.
Yeah, so
That's not a question either.
one scenario we came across was one where we're creating like sequences of DNA. They were called peptides or something. It was easy to generate on the fly, but the problem, if you had to generate them all beforehand, you had to store like how much was it? Close to maybe 70 gigs, something like this, continuously. But you could easily start generating on the fly and doing, maybe not generating all of it, depending on the user request, generate parts of it. The problem is you generate it, store it, index it, but then a user will come and question about the data. So you have to re-index it and to optimize it for other questions. So this could be a possibility where huge amounts of data, if you have the possibility to regenerate it, that would be one thing. Also, workflows, many of the workflows have a lot of intermediate data that you don't need all the time, but you know how to generate it when you want to reproduce the results or something like this. So this could be scenarios where you set in your data store and say, okay, I have this data, and these are the functions how to generate it. It's up to you to delete that data if you're low on space, or keep it somewhere.
Oh, the questions are starting to flow.
One more comment. I think I read something a couple of weeks ago where either was Google's or Facebook's AI lab where they use small images of nature, objects, whatever, and then they were able, using machine learning algorithms, to scale up the images while still keeping the information that is already in the larger versions of the file. Is that a similar idea, what you're thinking about?
Yeah, could be. But do you know what it was called, or do you know it was Google or Facebook? Do you know who it was? Was it Google or
No,
Facebook? No.
but I can find it.
So this is also more of an observation than anything else, a potential use case. The SKA that's been built in South Africa, square kilometer array, they're going to be producing just in their first phase 160 terabytes of data per second.
Mm-hmm.
If you're analyzing it as it hits the storage and then dumping the raw and storing the product, that could be a potential use of this resource.
Yeah. Astronomy scenarios are one of the scenarios I had in mind, because I came across also another project where satellites gather raw data from the satellites, obviously, but this is raw data, and scientists are continuously apply filters on this raw data. But because of provenance, they want a way how to go back to the raw data and the multiple stages of the filters. So that could be one of them. You don't need to store everything, you just have the raw, and applying the filters, you always can get the data back.
I'll allow a last question.
Right. This is a comment as well. Sorry. Oh, you wanted discussion, so this is discussion material.
Yeah.
Very good. I think it's a very good approach because we need a way of decoupling and bringing compute closer to storage than performance benefits. Things you didn't mention, but you could, from a
Mm-hmm.
see what they did and what happened there. See if there's lessons learned.
Yeah. So its name was Virtual.
Virtual data grid.
Oh, yeah. Well, that's good to know. Yeah.
And with that, I would like to thank the speaker one more time.
Thank you.